In the previous video, we learned how to set up both free and constrained modal analysis in Abaqus using HyperMesh. This was the result of the free modal analysis, where the seventh mode occurred at approximately 5.4 Hz. In that tutorial, we used 1-to-1 rigids to connect the two components. But what if you don't want to use 1-to-1 rigids? There is another method available in Abaqus tie constraints. In this video, I'll show you how to set up the same modal analysis using tie constraints to connect the two components. First, I'll delete the existing 1-to-1 rigids. Now let's create the tie constraints. Go to Contact, select the tie card image and create a new tie definition. For the master surface, create a new set. Make sure the selection type is set to elements. Now select the required surface and click OK. Notice that the surface normal is pointing outward, which is not what we want. Simply reverse the surface direction. That's it. Our master surface is now ready. Next, we need to define the secondary surface. Create another set and select the corresponding surface. Since this is a solid face, its normal automatically points outward, which is correct. Our first tie constraint has now been created. We'll repeat the same procedure for the second connection. Duplicate the tie definition and assign the second pair of contact surfaces. Create another master set and select the required face. Then create the corresponding secondary set and select the matching face. Now both tie constraints have been created successfully. If you press Q, HyperMesh displays the two surfaces that will be connected by the tie constraint. One surface acts as the master and the other acts as the slave. We'll discuss the guidelines for selecting master and slave surfaces in a separate video. For this example, either surface can be assigned as the master. Now let's look at a few important options. The first one is position tolerance. This value must be large enough to include the gap between the two surfaces. In this model, each component is 1 mm thick, so the tolerance needs to be greater than the separation distance. A value of around 9 mm would work, but to be on the safe side, I'll use 15. Next is the adjust option. If you set adjust yes, Abaqus moves the secondary surface toward the master surface to eliminate the initial gap. In our case, we don't want the geometry to move, so we'll keep adjust no. We'll use the default surface to surface formulation, and since our position tolerance is already sufficient, we'll keep the remaining settings unchanged. Apply the same settings to the second tie constraint as well. Now everything is ready and we can safely export the Abaqus input file. If we open the exported input file, you'll notice that Abaqus has created the TI keyword with our two surface sets, a position tolerance of 15 mm and adjust no. Let's submit the job and wait for the analysis to complete. The solution has finished successfully. Now let's import the results and compare them with the previous model. This is the seventh mode obtained using 1-to-1 connectors, and this is the seventh mode obtained using tie constraints. As you can see, there is almost no difference between the two results. Let's also compare the 8th mode. Again, both results match very closely, confirming that the tie constraints are working correctly. You can download the model files from the link provided in the video description. One additional option is Adjust, which automatically closes the gap between the master and slave surfaces. However, in most modal analysis problems, we simply want to establish the connection between the master and slave surfaces without modifying the geometry. You can also enable the no rotation option if required, but for most applications, the default settings are sufficient. That's all for this tutorial. Thanks for watching and have a great day.